Okay, we have a quadratic equation or function in standard form. There's a, b, and c, and we are to find the vertex using negative b over 2a. So b is negative 8, so we're going to do positive 8 divided by 2 times the a number, which is a 4, so 2 times 4 is 8. 8 divided by 8 is 1, so the answer to the problem is 1 comma something. We just need to plug the number 1 back into the function. So 4 times 1 squared minus 8 times 1 plus 10. 1 squared is 1, so 4 times 1 is 4 minus 8 plus 10. 4 minus 8 is negative 4. Negative 4 plus 10 is 6. So we're done there. Letter B says use the vertex to rewrite the function in vertex form. Vertex form is the a number times x minus h squared plus k, where h and k is the vertex, and the a number is the same a as in standard form, so a is 4, and then we have these parentheses squared. Remember that because the formula has a minus sign built into it right here, and we're about to plug a positive number into that, so that's going to look like x minus 1 squared, and then the k is the number 6, so plus 6. We're done. The lowest point the graph of the function reaches. Well, first of all, we know it's a lowest point because this a number is positive, which means the graph of this thing is shaped like a U. It's U-shaped. And so the vertex, by definition, is the lowest point. So the lowest that it goes is 1, 6. But in a question about how high up or how low or high it goes, it's really just the number 6 that we're worried about. So I'm just going to answer this as the number 6. Letter D says, what is the domain and range for the function? Well, domain for a quadratic function is going to be all real numbers. There's no restrictions on that. It goes forever to the left and forever to the right as far as the graph goes. But more importantly, you can plug in any kind of number into it that you want to. The range, however, is restricted. It's going to relate to the vertex, and so in this case it's going to be all real numbers with an exception. This graph, like we said, is U-shaped, so it goes above the number 6. So that's what question C was trying to hint at. All real numbers greater than or equal to 6. Technically, you could just write that as all y numbers greater than or equal to 6, like that, and that would have been perfectly fine too. Alright, so question 2, a student was trying to find the vertex and showed the following work. Find their mistake. So let's see if we can track with what happened here. A is 2, B is 8, C is negative 12, so that line is correct, so I'm just going to put a check mark right there. The formula says we were supposed to do opposite of b over 2a, so there's the negative 8 divided by 2 times 2, and indeed 2 times 2 is 4, there's the negative 8. So they didn't make the mistake of forgetting the 2 opposite of b, so that's all good. So it appears to me that that second line is correct. So after you find that number, we go and plug it in. So this is their attempt at plugging it in, and you may notice the issue is right here. They forgot to put parentheses when they plugged in that negative 2 into the squared spot. So if I was to correct that math, I guess right here, 2 times negative 2 squared does not make negative 8. Negative 2 squared is negative 2 times negative 2. That's positive 4. 2 times positive 4 is positive 8. So it should really be, 8 plus 16 plus 10. And that makes, let's see, 16 plus 8. 26 plus 8 is what, 34? So the answer should be negative 234. Moving on. Number 3, just wanted you to do some mental math. Just been noticing some issues where people pull out their calculators in class, and I just wanted to remind you about some of these things. You can do them. So whenever you minus a negative like that, that double dash thing basically becomes a plus sign. So that's actually 10 plus 2, and that is 12. Letter B, we have a negative 5 minus 3, so it's kind of like you're in debt $5 and you borrow 3 more. So that grows as far as the number goes. It might help to think of that problem as being negative 5 plus negative 3. That's one of the things your elementary school teacher probably taught you to do or whatever. Negative 5 plus negative 3 is negative 8. Letter C, just wanted to remind you that squared comes first, so 4 squared is 16. And 16 minus 20 would be essentially the same thing as 20 minus 16, but it's got to come out to be negative 4. Letter D, I threw in some x's here, so 4x minus 9x would be negative 5x. Letter E, that's multiplication going on, so negative 2 times 4 would be negative 8, and then x times x is an x squared, something I've been noticing students forgetting. Letter F. We need to do inside the parentheses first. That's why there's the whole like, please excuse my dear Aunt Sally, the PEMDAS. P stands for do the parentheses first if you can. So 2 minus 5 would be negative 3, and then we still need to square that, which means do negative 3 times itself, which gives you a positive 9. And we're done there. Number 4, so we have we're supposed to find the roots of this function, and it's already in factored form, and we have told you to look at these parentheses here, and it's basically the opposite of the number you see right there. So if you see minus 9, then the root is going to be positive 9, and x plus 1 means it's negative 1. Now, to give you a little bit more detail on that, actually what's happening is we're solving a little equation, x minus 9 equals 0. So we're actually, it's not about opposites, it's just about saying what number minus 9 is 0, and that number is 9. In the same way here, what number plus 1 gives you 0? Well, that'd be negative 1. Alright, number 5, we have the vertex, or we have a function in vertex form, which means your two numbers is that and that. So it's, again, because of the vertex formula, it has a minus sign built in right here. That means that somebody input a negative number into that, so it's negative 5. So in class we've just been saying it's the opposite of the number you see in the parentheses, and then the second number is just what you see back there. Alright, and now number 6, one of our newer topics, simplifying square roots, radicals. So the question is, what number from our list of perfect squares, which let me just make a quick list, 1, 4, 9, remember that's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and that's going to be big enough for what I need to do here, but technically that list keeps going. So which one of those numbers, what's the biggest number that goes into 27? Well, 9 does. 9 times 3 is 27. The beauty of that is square root of 9 is actually just the number 3, so I put 3 square root 3, and that's my simplified final answer. Number 1, well, that's just labeled wrong, sorry. We'll call that letter B. So 75 can become 25 times 3, and square root of 25 is 5, so 5 square root 3. Number 2, sorry, letter C, whatever, third one. Square root of 24, let's see, the biggest number that goes into 24, I guess would be 4. So square root 4, square root 6, and then the square root of 4 is just the number 2. And we're done there. Alright, we do have a ACT this year, so here we go. What is the probability of randomly choosing an odd number from the set? So, probability, you might recall from, I don't know when you guys have learned probability, but probability is a fraction where the fraction is made out of so the denominator is your total possible outcomes, and on top of the fraction is sort of what you might call the desired outcome. So in this, what you'd call a trial, we are trying to figure out how many odd numbers are in this data set. Well, let's see, let's underline that. So there's the number 7, the number 9, the number 17, and that's all of them. So that's 3 out of, and then how many numbers are there? Now in this case we add up all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers total, including all odd, all even, and then we can reduce that fraction down to 1/3, and we're done there. Sometimes you give probability as percents, so that would be 33.3%. And we're done. Good job.